Okay, so we should be broadcasting now, and I want to talk about animation, and in particular character animation. We want to move the bodies of people around in the environment, and there are several steps to this. There are several steps to bringing a body to life. And one really crucial part, well, first of all, you need to have a body. You have to have a model that you want to move. The models can be taken from many different sources. I mean, you can, maybe you're, what do you say, ambitious enough to build a model from scratch. And you can certainly do that in a modeling package like Blender. You can build them cube by cube, or essentially like what the great sculptures always said. You start with a big block of rock and then take away everything that doesn't look like a human, and you have a human in the middle. It's in there somewhere. It's just a matter of finding it. So in Blender, you can actually start like that. Like if you're really ambitious, like I said, just build a lot of cubes and then take away the cubes until you have some kind of a form in the middle. Or you could just do it, polygon by polygon. You can shape it into a human body shape. But then you have a collection of vertices. So the human model is just a bunch of vertices explaining the surface of that human. But they don't move by themselves, certainly. And if you could imagine maybe that if you wanted to animate a model built up of 20,000 vertices, you would basically record the motion of each vertex. And you could maybe pose this character in two different poses by grabbing a bunch of vertices, moving them to the side, and then say, here's a new pose. And then you can save maybe two versions of the human, one like this and one like that. You can't do that. You can actually, by hand, move every vertex that makes up a different pose. But that's an insane amount of work, and it's prone to error because you would be picking out these little vertices every time you want to make a little bit of a movement. This can be done. In fact, you can even bring in the model completely raw into Unity and access any of these vertices at runtime. You can make a script that at runtime takes a vertex and moves it, and that's like a beginning of some kind of an animation. But again, if you have 20,000 vertices to move to make one little hand movement, that doesn't make any sense anymore. So we simplify. We really, really simplify the process of animation by introducing a skeleton. And the skeleton is therefore a really, really important part of making animation simple and useful. And a skeleton, well, it's just like a human skeleton. It is something that sits inside the model. So you have the model and you have the skeleton. So two separate objects. You put the one inside the other one. You put the skeleton inside the model. And then typically in a tool like Blender or 3D Studio or something like that, you associate these two things. You grab a bunch of vertices and you associate them with a certain bone of the skeleton. So you can grab the vertices that describe the arm, you grab them all and you stick them, you kind of tie them to the bone that's inside that arm. And you're essentially telling those vertices to look at that bone, and whenever the bone moves, you move. So you, as a vertex, you follow the bone that you have been assigned to. So you can assign, 1,000 vertices to one bone on the arm, and whenever that bone moves, all of those 10,000 to 1,000 vertices, they move. And you go through the body like this. And this is a process called rigging. So you are rigging the character, but when you take a model and you associate it with a skeleton, when you build a skeleton, you can build a skeleton from scratch using certain bone elements that software like Blender gives you. So Doing humanoid animation requires the model and the skeleton and the rigging having taken place. And the rigging also involves naming the bones so that you can address bones specifically. And at that point, you bring the character into an environment like Unity. Once you have a rigged character model, then you can bring it into Unity, and then I will show you how to make it move inside Unity and using the Unity tools. So again, you can make it completely from scratch, but one way to, well, you can also find, when you look for characters and you want to animate them, look for already rigged characters. That's usually best, because then you already have a skeleton in there and you don't have to do a lot of work. If you really want a character and you don't have a skeleton, I could maybe show you how to do that in Blender. You can actually build your own skeleton in Blender and then rig it from there. There are some online tools even that allow you to rig characters online. You basically upload your model and then they will assign a skeleton for you and help you rig it from scratch. And then you can export it again. And then there are tools that are specific for creating humanoid models and already kind of automatically rigging them. And I want to show you one tool that is kind of an interesting tool that is completely open source project, very ambitious project. It's been around for a little while, and it's called Make Human. So this tool here, Make Human, was specifically created to make any possible humanoid or human model that is sort of correctly proportioned and everything. And this tool allows you to shape also these models. So in theory, and they actually allow you to do this, is you can bring in photographs or drawings that you made into the background and then try to shape the character to fit those drawings or photographs. So you might actually imagine, you could imagine using this software to make a duplicate or a clone of someone else. And there are some YouTube videos. If you look for Make Human and Barack Obama, I think you will find that some people try to recreate him in this environment. Now this model here, it has high-level adjustments. So instead of working on vertices directly to shape this model, they have done things like here's like a really macro variables, such as the gender of the character. You can make the character super macho by going this way. It's like, hey, here's the macho meter, and you can just drag that and make him like that. You can do the muscle meter, less and greater. You can do weight. So if you do very little muscle and a lot of weight, you get something like that. If you do a lot of muscle but a lot of weight, you get something like that. So you can pretty much just make any type you want. Even the age is kind of a crazy one there. You can do the proportions go like all the way down to a child and to a kind of a bit of hunched old person. So you can imagine making anything you want here, but by default, these characters that you make in here, they don't have any skeleton. This is just the model. Actually, let me do the material also. I think there are a few materials you can assign to this. Excuse me. He's a very pale looking guy. If you go to animate, there you have to assign a rig to the character if you want to use it in Unity, for example. And by default, there's no rigs. And if you press the default rig here, it actually builds a skeleton. So now you see the skeleton appearing inside the body. And this is really a separate object that defines the hierarchy of bones. And every single bone here has a name. And it's already associated a group of vertices to each of the bones. And so now that I've done this stage, I've automatically rigged this character then I can just go and save it. And I can save it, and I'll go into, yeah, I'm in the right folder right there. So I'll do demo 5 guy. That's the default format, is just their own proprietary format. But if you go into export, then you have a choice of all sorts of formats, including FBX, which typically something that a lot of tools understand. FBX, and I think everything else is perfectly fine. You don't have, if you want to make your own texture for the character, then you would maybe export a UV map that you can then paint yourself. But let's just do this, export FBX. That's the only thing we'll do. And here we are in Unity, back in Unity. And we'll start with putting a plane, a ground for us. Make it kind of big. Okay, here's the ground. And I should find now the demo guy is in here. And I should just be able to drag him. Oh, sorry, this is the demo. This is the game view. Okay, here we go. I'm gonna drag this guy in here. Here he is. And if everything is correct, then he should be standing there. Yeah. Change the light. So here. So here he is standing there. He is already rigged, so he has the skeleton inside. We don't see it, and he has the model, but he has not been associated yet with the Unity animation system. I mean, it could have been that if you created some kind of a model in a different package, like Blender or Make Human, that you come up with some skeleton of your own, own creation. You just basically name them. Let's say you name them in Icelandic, the different bones, or a different language. Unity is not going to know how to talk to it. I mean, you would not know how to address certain body parts that you bring in. So Unity needs to know these things. It needs to understand, you could say, the semantics of the body that you're bringing in. So you have to teach Unity this. You have to let Unity know about what is what. So when we bring in a model like this, let's actually delete him again. You can choose him down here. You can choose it. You can find him down here. You also see import options up here for bringing him in, and you can look at model import options, rigging import options, and animation import options. Here you see one part there. There's the rigging import options. So this is how should Unity treat the skeletal part when Unity brings it in. Well, one thing we can tell Unity is that this is a humanoid. That's already a big step. We're telling Unity to expect something that has 2 arms, 2 legs, a head. That's an important step for Unity to understand what it's dealing with. So we'll tell Unity it's a humanoid rig, and we want to define what they call an avatar. An avatar is really nothing. Is really just an interface to the human body, to the humanoid body. It's like a control interface that Unity provides to humanoid characters. So we want to create that interface from the model itself. So meaning that because it's already rigged, it already contains a skeleton, we just want Unity to go in there and try to link with it and extract from it all the right control points. So we'll just do that. It's a humanoid, and our definition should come from the model itself. I think we can do apply here. And then we can configure. We can actually see if this is working properly. Let's press configure. Okay, we'll just save the scene. Let's see, demo 5. Save. Okay, so I went into configure here. And the configuration shows me actually how it has already mapped out the body into different body parts and skeletal control points. And the interesting thing is that Unity does this all by itself. Let's see if I think I can look at him a little better. And you can see the skeleton inside there. Why is the guy so far away there? So Unity has now automatically mapped this type of an avatar interface to our body, and is now allowing us to test to see if the mapping is correct, if it has found the right joints, and it has applied what it calls kind of muscles onto this the body, and we can try to move the muscles. So and now see how they work. So here's a kind of a sequence of muscles that is activated to a certain degree to make different poses. So using this muscle group preview here, we can see how Unity is addressing several muscles at the same time, changing them. Each muscle in turn is then controlling a certain part of the skeleton. And we can see that these muscle groups, they seem to work very well together, in fact. We seem to be getting movements that make sense for a human. And this is just to test that this mapping has been successful. You can then, these are muscle groups up here, but you can also go into individual muscles and say, so, okay, how is the neck going? Is this muscle correct, for example? And it looks like the head bones have been correctly identified, or neck bone, so that we can in fact make a head nod by addressing that specific bone. So this is really good. We didn't have to do anything. In fact, we can just be happy if we say that we are done. So that this means now that our demo guy down here, he has now been mapped, and there's a demo guy avatar that is now bunched up with him. So there's already now a control interface, a humanoid control interface, ready to be used for this character. And now when we bring the guy into the scene, we can potentially make him do things. Here. Maybe I should put him in the center here. Yeah, here we go. Okay, so this is a humanoid character, and when we bring him into the scene, we get an animator component already associated with that. And if you look at the animator controller, component, we see that there is one thing missing here from the parameters of the animator, and that's a controller. And a controller in Unity, an animation controller, is essentially something that triggers animations, moves between animation clips. It is set up like a state machine. If you're familiar with state machines, um, an animation controller is always in some kind of a state. And within that state, it can make the character perform certain animations or actions. And then you can tell the controller to move to another state, and then the animator controller will make sure that it's now playing back some other animation. So you can set up your own state machines that determine what range of movement this character is capable of, and also how you go from one movement to another movement. So that's what we're going to do next, is to add an animation controller. And we can do this by adding a new game object down here. We can just do a create new here. I'm going to do a create new animator controller. That's going to create an empty controller object. And I'm going to call it demo 5 guy controller. I mean, of course, now I'm tying it to a specific character, but you can imagine making a controller that many characters are using. So you could actually create, let's say you create an animator controller for the general NPC. And then that would just be the same state machine for all of the NPCs in your world. And that's perfectly fine, because they could all be in different states, but they would be following the same type of movement scheme, essentially. So maybe let's just call this then just a demo controller. So it's not associated necessarily with one specific character, but now that I have it, then I can select my character and I can drag this controller into that parameter here. So now it has a controller. But this controller does not do much. And if I play this, okay, that was funny. He's down below. Why is he down below there? Plane. Was it just that? Oh my God, he's doing some kind of a movement. I probably left him in some very weird state. Yeah, the avatar. No, reset. And I didn't leave any of this, no? And this controller, no, there's nothing in there. I'm gonna throw them out again and put, okay, this is this guy. Oh. Putting him here. There he is. Okay. And then I take the controller and stick it in here. Okay, so the controller is putting him into some kind of a state that is kind of making him do a weird thing. Let's just try to put an animation clip and see if it's trying to play some nothing essentially. So maybe that's what's throwing him off. So, sorry, what I was doing there is that I have the demo guy here. I put the empty controller in there that I have created. And now I just double click on the controller and I get this view. And this is where you construct the state machine. This is like a visual editor for showing what clips to play and how to transition between them. Right now, there are no clips in this view. There's nothing to play. The state machine will just jump into the entry point here, but it has nowhere to go. There's nothing to do. And if you want to add things to do, you can go into your project browser and look for animation clips. So now I'm just going to filter for animation clips, and it shows me all animations that I have in my project. And you can import animations from the asset store. There is like a whole package of raw motion capture data that that Unity provides for free. So you can bring those in. And if we take, for example, one of those, you can look for, it's good to look for idle things. So if you look for idle, here's a bunch of idle, humanoid idle is here. So you can grab this and you just drop it onto the state machine here. So now this animation is what's going to happen. You can preview it down here. So that's the animation clip that is now the first action that will be taken by this animation controller. And it loops, it's fairly short and it loops. So that's actually a good thing. So, well, we can try it now. It worked. So just by dragging that one clip into our animation controller, and then that's really the only state that the controller can be in. And it loops that state endlessly. And you can see, if you look at the live view, you just switch to the animator view, you can see a live view of the execution of this. And you can see that it's playing this clip. And this is the length of the clip. The clip will end over here, and then it will loop back and then start playing again. So this is really shows you how far along the clip it's already played. But this is, of course, a little bit boring to just have one possibility of movement. So now we make things a bit more exciting by adding maybe another clip to this whole thing. And we can try to get, these are mostly locomotion things, but we can try to do some, I guess some kind of jumping would be, or crouching maybe. Let's see, crouching. So here I have a crouching. We can take a look at that one. We can preview that one. So look at the crouching here. Crouching is actually just being down there and doing this. It's not any particular movement. It is no going down. There's just being down and doing this. You'll see what I mean in a minute. So let's use this. And now I need to have a way to get from this idle animation over to the crouching, and then maybe we should go back as well. If I right-click on the idle one, I right-click on it, it gives me the make transition option. The make transition, when I click on that, it gives me this rubber band arrow, and I'll drop the rubber band on top of the crouching. And then if I do it like that, I can just actually preview this already. It does idle, and then he goes crouching. And then he's stuck there. He doesn't do anything else. And why is that? It's just a one-way trip here. We go into idle, he plays idle, and then he goes into crouch, and he plays crouch, and you can see it running here. Oh, sorry, I was going to preview it here. It ran idle, it went out to crouch, and in crouch it just continues indefinitely to repeat crouch. We could maybe make a transition back to idle, but then what's gonna happen now? It's going to do crouching, it's going to do idling, it's going to do crouching and idling and so forth. So that's going back and forth between these two states and always finishing the animation before going to the next one. This is not very interesting. We would like to have some of the transitions to other states and therefore animations to be meaningful and be a response to something. So we can work on the transitions themselves. We can select the transition like this one, and we can look at some different options about this transition. There are two main things to maybe look at here. One is the blending that happens between these two animations. As you could see, one is standing like this, and the other one is like that. There's no poses between, and that can look very abrupt. It can be like ding ding, you know. So, but we'll come back to that in a minute to fix that. But the other thing to look at is the conditions. What is the condition that has to be true for this transition to happen? So if that list is empty, so there are no conditions on this transition, so it'll just happen automatically. What we want to do is to, let's say that we want a key. If you press a key, then you actually do crouch. So you can maybe use the crouch key, which is often C on the keyboard. We want C to affect this. And the way to affect any of the transitions or any of these states inside the animator controller, it is through parameters. So the animator controller has a set of parameters that you decide, you define, and that's like the control interface. So you essentially, you create your own personal control interface to this animator by setting up. So we are saying we want a crouch action to be, you know, callable. We want to be able to make crouch happen. So we need a parameter for that so that we can control it from the outside. And right now there are no parameters. This is these are two tabs here. There are no parameters in our controller. There's a plus here. We can make a new parameter. We can make parameters of different types. And the one that we are looking for right now is the trigger type, because the trigger type is basically a Boolean. It's a true value that you can give to this parameter, but it's instantaneous and only once, and doesn't remain true. And that's useful when you just want an action to take place as a response to a one-time event, not as a response to a state that is like a permanent state that you're in, which will be a difference between bool and trigger. So trigger goes true and then back to false, but bool, you set it to true and it will stay true. Let's use trigger, and we'll call it, we'll just call it crouch. So this is a crouch trigger, essentially. So now we have added a parameter, and we can go into the transition here again, look at the conditions of this transition. That list is empty. I can now add a new condition on this. And it gives me all the parameters. It would drop down here with all the parameters that potentially could be used as conditions. And I only have one so far, and that's the crouch. And I'll put that as a condition for this transition. And now, if I play it, what should happen? It crouched. I'm baffled. Crouch is there. This transition requires crouch. And crouch is, let me see here. If we watch the animator, what does it look like? Okay, just idle. That's what I expected. Okay, it's doing what I expected it to do. I don't know why the first one didn't do it, but you can see that it's only in the idle one. It is not transitioning at all over to the crouch one. Unless I set the crouch parameter, and now it jumps because it felt the crouch trigger. And I can do it, using the user interface, turning the crouch on and off. But that you can't do that. That's not the way that the script would work. You would have to call this somehow to make or create a script that actually calls this to make that transition happen. But I've set it up, so now I have completely set up my animator controller with a nice scriptable interface. And I've not done any line of programming yet, which is kind of nice. This has all been just visual editing. But now we need a little bit of programming to tie this to a key. So for the character here, I'm going to create a new C# script, and I will call this I'll just call it demo 5 input, for lack of a better term here. Okay, reload. I don't have to. Okay. So here's just a regular script. And what I want to do is to detect a key press and then use that key press to change the parameter in the controller. The first thing I have to do is that I do have to get the animator. Get access to the animator from the script. I think this should work. We'll just try. But I remember when I said that we want to, if we are retrieving references to any other objects or components, and like we want to try to set that up in the start method, because then that's all ready for us to use, and you don't have to call find and all of these things again and again. So we want everything that we want to use, we want to set it up here in the start. So now this script should have access to our animator component, and the animator component contains the animator controller. But if I remember correctly, we should be able to do down here. Oh, we'll do the key checking first. Key down and key code. What was the crouch key? C. C. Okay, so now we have detected an event. Keep pressing the C key. And now we want the animator to do something, and we want to use the interface that we created. And to do that, we have to do we have to speak to the parameters that we have given it. And these parameters that we gave, it is just, they have names that are just strings. We were not doing any programming. We were just setting up certain names and values. And so to access them, we use special methods. Set, and then the type of the parameter, and then the name of the parameter. And well, hopefully this will work. We are then setting the trigger with this name. So we'll save this, and we'll take this script, and we will add it to the demo guy down here. So now the animator and our key input script are both here in the same game object. And let's see what happens. Okay, he's there. And if I press C, look what happened. And you can see it in action if you switch to the animator. You can see it in action. You can see the crouch parameter up there. And when I press the C on the keyboard, hey, I'm not seeing it doing it. Oh, I see. I have to be in here. Sorry, I'm pressing the C in this window. I have to move this window over here and then be in this window so the user input can be detected, right? So now, here you go. So I'm pressing the C in this window, and that's where you can see it lights up the button, and then it does the transition. But there's one a little bit annoying thing about this. If I'm pressing the key now, it still waits for this complete animation to finish before crouching, which is not very responsive. You know, you want the crouching to happen exactly when you see. I'm pressing key now. It doesn't crouch until it finishes the current animation, and that's because this animation in here, it has a certain length, and it kind of requires that length to finish before it can do anything. Let's see. Oh, there was. Doop-doo. Okay, so on this transition, if you select this transition, then the exit time can be unchecked. Let's see if that helps us. Yeah. So by selecting this transition and then finding under the settings, the has exit time. Actually, it's not in the settings. It's just right here. Has exit time. If you uncheck that one, then it won't wait for the determined exit time. It will just use whatever exit time you give it, which is now when you press the key, and then it will exit the previous state into this state. So that's pretty much it as an introduction to this. Maybe a couple of more things I can say about it. So the trigger type is very useful for things like, oh no, sorry, I was going to go back to the blending. Let's finish that. So as you notice now, and I press the C key, it is quite drastic. It is still a little bit of blending between these two poses. You can see that he is in between sometimes. If you want to smoothen this out, and if you want to go a little bit more gradually into your final pose, you can play with the blending on the transition. So I have this transition selected. It shows me the previous clip and the next clip, and it allows me to extend the period where it is blending between the two. And let's see if I think it just does this already. Yeah. You see what happens? So I press now. So it is doing the humanoid idle. At this point in that clip, it starts to blend in the humanoid crouch. And this blue line tells you the strength of each clip at that moment. When all of the blue is on the upper one, that means that that's 100%. And then just that one. And then you see that the blue one and the upper one slowly goes down to 0, while the blue in the other one slowly goes from 0 up to 100%. And so at the end of the transition, we have 100% this, 100% in the beginning, 100% that. In between, it's being blended and weighted. And we can extend this blend or we can shrink this blend. And the most drastic one would be like if we had if we made it like this, where there's basically no period of blending happening, like that. This would mean that it just plays that one and then quickly switches 100% to the other one. And that's when you get that really abrupt one like that. So you can play with this to make it smoother or less smooth. So, and the other thing I wanted to talk a little bit about is that the parameters that you have here, you can play with them different types. And one interesting type you could imagine is you can use float and integers. And let's say that you want to have, let's say that you have an animation that shows the character in an angry state or something like that, you know, like something that reflects some kind of an inner emotion or something like that. You could associate that with the floating point number like this and say anger. And let's say the anger is none at the beginning, it's just 0. But then different things can happen in the world or the interaction that kind of pump it up a little bit and make it more and more, gradually higher. That means that I don't think we have an anger animation here. Maybe just something like that. We could, for this transition, we could add now the anger parameter. And look, when we have something other than a Boolean or a trigger, we get, like, we can make an equation of sorts or a comparison here. We can say when anger is greater than 0.5, for example, then do this transition. And then in our script or whatever, elsewhere in the program, we can do things like increment anger. And then this will trigger when it goes over a certain threshold. And you will change the state of the character. The character will do something. So that's one use for floating point parameter, is that this is some kind of thing that you can shape and give exact values. So that's that. And then maybe, so from the script, of course, and if you want to just quickly see how if it works, I could do this here. I could just do, maybe this is the anger key A, and I can do something like that. This is very, very poor, but I think it does the. I think this does what we wanted to do, which is that we have some kind of floating point value keeping track of the character's anger, and then when we hit a key, we can maybe increment this this floating point value. They could not, should happen probably in an interaction with a person or a human or something. But then we update the anger parameter in the animation controller, and then this would in turn change. Actually, we don't know actually what he's going to do, but let's just see how he does. So we play it and we do, what was the key? Anger. Okay, he's still not angry. He's still not angry. Still not angry. We're getting up there. All of a sudden, he starts pointing. So now he's really angry. Oh, it's time to reach the mouse. It's time to reach the mouse button. So this is just because anger is above 0.5. One last thing before we just stop, because we didn't take a break. We will just stop here after this. One thing about the possibility to create layers in animation control. So in what we've been doing so far has been, we've been running full body animations, full body idle animation, full body then crouching, and now a full body like a reaching up animation. But sometimes we want more things happen at the same time. So one very obvious example is that we want a character to walk around, so the legs are doing a walking motion, but then maybe with the upper body we want the character to play a different animation once in a while, not a full body walk all the time and then stop walking and then do another animation. We want to do the walking and then maybe waving while they're walking and things like that. One way to organize this type of, you could say maybe complex animation or coordinated animation is through layers. So we can look at the layers right now. We only have one base layer. There's only one place where everything is happening. Typically, you would have maybe a layer for the locomotion animation system. So the layer that takes care of the lower body maybe could be all in some kind of a base layer here. And then you can add on top of it other layers. So for example, you could make a gesture layer. You can see that when I make a new layer, it just becomes empty. There's no animation in this layer, but then these animations are in here. You could take this one out completely, leave the crouching and idling to the base layer. But in the gesture layer, maybe you want to create some kind of an idle idle there as well. And then grab. So these would be in a separate layer from this base layer. And then transition to here. Oh, sorry. Transition back and forth in there. So now we have two animation systems. This system is to do the crouching up and down, and then this one is just to do the arm grabbing up there. And we can still make that one depend on the anger parameter, like we did earlier. Like that. Or maybe you should just do it lower like that. So then the question becomes, how do you make these layers work together? Actually, let me just see what happens if I run them both now at the same time. I think what is going to happen is that even if I have the anger one, yeah, the anger is quite high, we don't see what's happening on this layer. Do you see that that there's a blue line here, full extension of this blue line? There's no blue line down here. This is actually the weights of the different layers. If we want, you can actually make them, blend them all together. And so you can change the weight. You can change the weight of this one, for example, to 0.5. So now the blue line is a little bit higher there on the gesture layer. And when the anger happens, it's actually now blending that gesture movement, the hand movement, on top of whatever is happening in the other one. So if I do the crouching, it is doing the crouching still, but the gesture comes on top of the crouching. So you can see there are two state machines now, one above the other, and they are simply blended together, where the weight of the gesture one is half of the weight of the first one. You might still not feel like blending the whole bodies like this is appropriate. So, for example, for the gesture one, maybe we don't care about the legs at all. And so it is not just the weight that you can play with. You can also do masks. So the gesture layer can have a mask associated with it that only says these joints are the ones that will be affected. Other ones won't. There's no mask in here right now, but I can create one. And I can go into over here, and I can do create, and I can do animation mask or avatar mask. It's a new mask. And let's call it the gesture mask. And in here, I can make the mask. And I can simply block out the parts or mark the parts that I am interested in. So this is a mask that only includes the upper body and the arms, not the head and not the legs. And I can now take this gesture mask and I can place it inside this this layer. Excuse me. So you'll see that this layer now has an M associated with it, which says that this layer is masked, and anything that happens in this state machine will only affect the portions of the body that have been painted green by that avatar mask. So if I press play again now, and I make the anchor up here, you see how the pointing now is actually a little bit better, because even if you see crouching, he's still pointing correctly. He's not changing his crouching position. Crouching position is held in place by the first one. So when I crouch, the crouching is completely controlled by the first layer, the base layer. But the gesture, the arm, is being controlled by the gesture layer. So this is how you can now build up several different functions and actions in the body and combine them different ways. Okay, I think I'll stop here. On Friday, you are going to do the same thing within the lab, where you will also, you should actually play with using a collision trigger also, so that in the lab you want some character like this respond to you coming closer and having the character maybe wave out you're doing something in response. So that will be what you will be doing on Friday. But any questions? Otherwise, we'll put this video somewhere, and then you can always ask, of course. And on Friday we'll try it out. All right. Thanks. Thanks.